Welcome to our last lesson, programming with C++ week 10. And today I'm going to learn about operator overloading. You have to understand what operator overloading is. We also talk about derived classes. We learn about derived classes. We learn how to implement inheritance and polymorphism. We spoke about polymorphism in our previous lesson, which was week 9. So now let's begin. Not to waste much time. Let's begin. What's operator overloading? Operator overloading defines how operators behave for user. For user-defined data types like classes like objects and structures like variables. So operator overloading in C++ program can add special features to the functionality and behavior of already existing operators, such as mathematical and other operators. So this is really cool. It's a really cool feature that allows us to define how operators work with our custom classes. So just think about it this way. When you write 5 plus 3, when you write 5 plus 3 here, the computer knows exactly what to do. It adds two numbers and gives you 8. But what if you have two objects of a class you created? What should the plus operator do then? So operator overloading lets you define exactly what happens when you use operators like plus, which is the addition sign, subtraction, which is the minus. We have the star, which is asterisk, the multiplication sign. We have the equal to, which is the double, equal to the assignment sign, and many others with your custom objects. So for example, if you have a point class representing coordinate, you might want 0.1 plus 0.2 to add their x and y coordinate together. Or if you have a string class, you might not want the plus sign with the addition sign to concatenate two strings. That's the operator sign. So let's revisit the operator signs. You have the arithmetic operations, which is the plus, subtraction, multiplication. You have the logical operations, the and or. The AND is the first one and the OR is the second one. We have the relational operation, which is equal to. This is not equal to. This is greater than or equal to. Less than or equal to. We have the pointer operator, which reference is the pointer. We have the memory management operator, new, then delete. Operator overloading types. We have the types of operator overloading. We have the function overloading, and we have the operator overloading. So let's have a look at the syntax. Return type, symbol here. Let's continue with operator overloading breakdown. So this is the breakdown. We'll talk about the return type. The return type of the function is what type of value the operator returns. And the operator is a special keyword that tells the C++ we are overloading an operator. The symbol is the actual operator we want to overload, like the plus, subtraction, division, less than. And we have the parameters. The parameters our overloaded operator will work with. Yeah, let's have a look at the structure. It's an example here. An example here. Continue. The rules for operator overloading. So forbidden overloading rules. We have the conditional operator. We have the conditional operator. We have the scope resolution operator, which is the double column. We have the dot operator or member selector, which is just the dot. We have the pointer to member operator. We also have the object type operator. Then we have object size operator, which is the size of. We have the object alignment operator. We continue. We have only existing operators. So other important rules is you can only overload existing operators. You can't create new ones. You can overload other existing operators. You can't change what the operator does with inbuilt types. So at least one operand must be a user-defined type. You can't also change the number of operands an operator takes. You can't change the precedence and associativity of operators. They all remain the same. Let's look at the advantages of operator overloading. The advantages of operator overloading. Well, why would you want to overload operators? Here are the main benefits. First, you have the simplified syntax, which allows the use of notation closer to the target domain. Close to the target domain. So your code becomes more readable and intuitive. Instead of writing point dot add point 2, you can write point 1 plus point 2. And our second point, we have consistency. That's similar support to built-in types for user-defined types. So your custom classes can behave like built-in types, making them easier to use. Then our third point, we have easier understanding. That's use of familiar operators with user-defined types. As using familiar operators makes your code more intuitive for other programmers. As we have advantages, we also have the disadvantages of operator overloading. The first point, we have potential misuse. If you overload operators in unexpected ways, it can confuse other programmers. So the abuse or misuse can lead to unexpected behavior. We have the second point as complexity. Complexity. That's overuse or misuse introduces complexity. Overusing operator overloading can make code harder to understand. And the third point, you have limited overloading. That's not all operators can be overloaded. As you saw earlier, not all operators can be overloaded. We continue with our derived classes. What are derived classes? Let's move on to derived classes. This is where things get really interesting. So a derived class is a class that is created from an existing class. Just think of it like this. If you have a general vehicle class, you might create more specific classes like a car, motorcycle, or a truck from it. The original class is called a base class or the parent class. And the new class created from it is called the derived class or the child class. So the derived class inherits all the members and functions from the base class, but it can also add its own unique features. The derived class is also called a child class or a subclass. Move to the derived class definition. This begins with the keyword class, then followed by the derived class name, then colon, followed by access specifier and base class name. Let's have a look at the structure here. This is the structure. Look at the structure here. Now, how do we access modifiers in inheritance? Let's revisit this. One big class definition begins with the keyword class followed by the class name. The structure here. Derived class definition. Store with the quotes. We have class derived record, public my record, public access specifier, character grade, character get grade. Now using access modifiers. How do you use access modifiers? The access modifiers such as public, private, and protected can be used in inheritance using derived classes. When creating derived classes, you can control how the base class are inherited using the access modifiers. You have the public inheritance, private inheritance, and the protected inheritance. For beginners, I recommend using public inheritance most of the time, as it's the most intuitive and commonly used one. So there is a syntax, class group record, public my record. You have it here. obtain a derived class using the access. Now let's begin with the public. If a derived class is declared in public access, then the members of the base class are inherited by the derived class just as they are. So for the public class is declared, the members of the base class are inherited by the derived class just as they are. And for the private, if a derived class is declared in a private access, then all the members of the base class become private members in the derived class. For the protected, the public members of the base class become protected members in the derived class. Private members of the base are always private in the derived classes. Let's have a look at the syntax. The first one is the public one, second one is the private, and the third is the protected. The third is the protected. Now let's revisit inheritance. Inheritance allows one class to reuse attributes and methods from another class. It helps you to write cleaner, more efficient codes by avoiding duplication. And we have types of inheritance. We have the derived class, which is a child, a class that inherits from another class called a parent. We have the base class, which is the parent, the class being inherited from by the derived class, the child. So inheritance allows us to create a new class derived from an existing class, the base. The derived class inherits the features from the base class and can have additional features of its own. This is a flow process. Inheritance is one of the core principles of object-oriented programming. Inheritance allows us to create new classes based on existing ones, promoting code reuse, and creating logical relationships between the classes. Think of inheritance like a family tree. A child inherits traits from their parents, but they can also have their own unique characteristics. Let's continue with the code. Have a look at the code. This is a look at the code of inheritance. Dog is here. What are the types of inheritance? We have 5 different types of inheritance, and that is a single inheritance, multi-level inheritance, multiple inheritance, hierarchical inheritance, and then the hybrid inheritance. Let's dive in this one by one. For the single inheritance, this is the simplest form. One derived class inherits from one base class. This is it. Class vehicle, the class car. So the base is the class vehicle, and the class car is the derived class. For the multiple inheritance, a derived class inherits from multiple base classes. So the base classes are the land vehicle and the water vehicle, and the derived class is the amphibious vehicle. And for the multi-level, this creates a chain of inheritance, like a family tree going down multiple generations. So the base 1, we have the class vehicle. Base 2, we have the class 4-wheeler, and we come to the derived class. That's the multi-level. Base 1 and base 2 are the multi-level. The derived class is the class car. Continue with the hierarchical inheritance. That's multiple derived classes inherit from the same base class. So the base class is class vehicle, and the first derived class is the class car. The second car is the class bus. That's the hierarchical inheritance. Number 5, you have the hybrid inheritance. That's the last one, hybrid inheritance. For this one, this combines multiple types of inheritance. So we have the class car. The base is the class vehicle. The class vehicle to the class car is a single type of inheritance. Then the class bus and the class car inherited from the base class vehicle, they are the double or multi type of the inheritance. And the class fare, they are all inherited from the base, the class vehicle. So from the class first base is the class vehicle, second is the class bus, and the drive is the class first. So that this type of inheritance is the multi-level. Hope you understand multi-level. Now let's come to the rules of inheritance. The rules of inheritance. There are some important rules to remember about inheritance. We have the static members. The static members are class dependent and are not inheritable. So static members are class dependent and are not inheritable in the traditional sense. Friend classes are not inheritable. Friendship is not inherited. The constructors and destructors are not inheritable. Each class needs its own. As for the inheritors, let's move to the polymorphism. Let's revisit from our previous lesson. Polymorphism means many forms, and it occurs when we have many classes that are related to each other by inheritance. It uses methods inherited from another class to perform different tasks. It redefines the base class member function in the derived class. So here, this is where things get really exciting. It's the ability of different classes to be treated as instances of the same base class, while each class can have its own specific implementation of the same method. Think of it like this: if you have different types of animals, they all can make a noise, but each animal makes a different sound. The dog will bark, a cat meows, and a cow moves. The action is the same, making a sound, but the implementation is different for each animal. Let's have an example with this. The code here, a polymorphism code for our previous lesson. Let's have a look at it. Look at this and continue here next. As we are ending our lesson, let's have a look at this. Class group. This is also a code. Yeah. Then we have a last week 10 and week 11 tags. Is you incorporate the use of classes, including derived class in tags on students' result display. You begin the video tutorials if you haven't. Sorry. So this is the tags. We've ended our lesson. Thank you for your time from week 1 to week 10 and 11. As we end this lesson, I hope and I pray that God will give you more knowledge and understanding whilst you are practicing your course. You'll gain better understanding too.